Hello, this is AKMS. Today we're going to do some ratios. Ratios is going to be a basic foundation for similarity of the geometry shapes. Okay, let's get into when we're talking about the geometry shapes, most important to start with the lens of any geometry shapes. We're gonna choose one of the sides and we're gonna work with the lens of those sides of the shapes. Okay, now when we say ratio, we can talk about a little bit about the numbers. Ratios. Okay, ratios, it's as a common stuff. We can take any two number. Let's suppose 15/3. Okay, which we can do what 5/1. The answer, of course, we're gonna get a 5. But in general, we can work with any two numbers. Let's suppose to be A and B. And when we do this kind of a ratio, it's important. We try to relate how much about the sides, how much the sides relates to another one. All right. More in general for the geometry, let's suppose so A over B, the ratio of A over B be any measure, length, area, volume. It can be all of this to measure same story, measure of those lengths, part of those lengths or area or whatever volumes. Okay. In order to get a bit more understanding, let's take one of the sides of, we're gonna work with a line. Let's suppose we have a line and we're gonna choose part of those we're gonna choose part of that segment, line segment. Let's suppose we're gonna choose this line segment and we're gonna take another point between these two points A and B. All right, let's this point be C. Now we can measure, we can take the stretch head and measure these lenses, of course. Let's suppose we measured and we have something like this. Okay, let's suppose we measure that AB5 and ACB3. Then by the subtraction law we can figure out BC, which is 2. 5 minus 3 is 2. Okay, now let's see what's happening when we choose any part of this two numbers and we try to see their ratio. Okay, what we can do, we can check BC to AC, AC to the whole length AB, or BC to whole length AB. Okay, so 3 options is possible for the ratios. Okay, okay, 3 options is possible. So within these 3 options, we can work a little bit. Now we understand that this is how two line segments relates to each other. For example, AC, if I try to see AC to BC, the ratio I see with the numbers, it's 3/5. If I want to see BC to AC, it's 2/5, or AC to BC, 3/2. Okay, how will this help us? It will help us whenever we try to do something parallel lines. Okay, let's talk about that. Okay, now Now imagine we have two lines, two intersecting lines. First, imagine we have a line 1 intersects line 2 at this point. Okay, I'm going to choose this point to be, this point to be any point. Let it be the beginning, let it be O. Okay, let it be O. And of course we can start to choose a little bit. We can say this is A. All right, we can say this is A, let it be A, let it be B, let it be C. This intersection ABC, okay, let it be D, let it be E, let it be F. All right, but the basic rule is to draw the lines, another lines that intersect these two, line 1 and line 2. When we draw another lines, we try to draw them, each of those lines, parallel. The rule is parallel. Why? We have, from my previous video, I talked about the transversal and parallel lines. They have a nice properties. Because of the angles doesn't change. Angles may be related to exterior, interior, alternative angles. Some pretty good theorems. There was we did discuss about that. So how are we gonna work with this in general? Okay. Now I'm gonna do a little bit, okay, rotation. Let's suppose this is my line 1. Okay, it's my line 1, and I'm gonna draw my line 2 from this point. Okay. All right, line 2. Now of course you can do it at any angle you want it, any angle, doesn't it? Now, important fact, parallel lines you can do either that way. Parallel lines you can draw any other under the angle, any angle you wanted, this angle, any angle. So in general, but in our case we're going to choose, let it be perpendicular, which we talked about this already. Perpendicular, it's 90 degree, and these lines, perpendicular lines, does not need to be at the same distance. Can be different. Okay, let's suppose something like this. All right, 3 parallel lines. Okay, I'm gonna say P1, P2, and P3. They're all parallel with each other, these 3 lines. Let's call it P1. Okay, parallel line, parallel 1, parallel 2, parallel 3. Okay, now and put the let's put the points. This is O, and let it be this point A, let it be this point B, let it be this point C. Now I'm not gonna put the bottom points like DF. We're gonna do something different. Line 1 we're gonna consider as an X. We're gonna consider as a x-axis, like in Descartes system. So, which in a Descartes system we have 2 perpendicular lines. We need the reference point. Reference points is going to be 0, 0. That's what is important. So we have the x-axis and perpendicular to that y-axis. We're going to show something like this. So let it be x-axis, L1, let it be here x-axis. Line 2 in our case, because it's taken under any angle, let it be angle theta, any angle. Now We know by the if this is theta, this is some other angle from previous video. We know that this angle over here congruent to that, and so on. Also this congruent to that, to these angles. All right, but we're not going to talk about the angles right now. We're talking about the ratios. All right, so what are we going to do now? On the x-axis, we're going to bring down these points, and what are we going to do? The foundation blocks was our perpendicular lines. It's very important. Perpendicular lines is going to be our locations, and in our case for A, we're going to wanna build its projection location, or we're gonna call it A prime. So this point is gonna be its projection on x-axis A prime. For B, it's gonna be B prime here, and for C, this point is gonna be C prime projection. That's very important. Now, why it's so important? Let's choose some numbers for this. For example, in geometry, there is a in the triangle, in the right triangle, which means one of the angles is right. If we choose this triangle, and we said let this parallel lines be perpendicular, so which means one of the angles is 90 degrees. In our case, this angle is 90 degrees. There is a so-called popular numbers which relates like 4, 3, 5. So let's choose this number. We can choose. We don't know this measure for now. We don't know this measure. But what are we gonna do? We're just gonna extend, and we're gonna do for the bigger triangle. Bigger triangle doesn't change the angles. These triangles angles, all these angles is congruent to this, all these angles. But from we see the sides change, the measure of the sides change. So let's choose let's choose it from 0 to from O to B, that part. Okay, let me do it. Okay, like that part be 8. That part be 8. That part be 8. Now that part be 8. Now what are we gonna do with the other parts? How are we gonna relate? That's what we said. Ratios. We can work it out now. We can choose either one of these options. We had it. 3 options. We had it. Either this one to the bigger, either this one to this one, or opposite, or bigger to the smaller. Now, because we don't know that part for now. All right, the total also we don't know. Okay, and we don't know this part. Let it be any number. Let it be x in our case. That part, let it be x. Then the total AB, the total OB is going to be 5 plus AB, and we said that AB, let it be x. AB, let it be x. AB, let it be x. All right, let it be x. From the line segment, now we can say from line segment O A prime, A prime B prime, or O B prime. We can choose any of this ratio. Let's choose, for us to make it easier, this AB2, we're gonna choose one of these. All right, we're gonna choose A prime B prime to OA to OA to OA OA prime, sorry, OA prime. Now by the subtraction law we know that this part is going to be what? 4, because 8 minus 4 is 4. Okay, so what do we get? We get 4 over 4, which is 1. This is good. Now by the ratio and the property of the foundation of the parallel. Now, important fact, where do we start? We start from here, this side, we went this side. So same story, this from X, from AB to OA, we have to come up. Okay, let me change the highlight color. Okay, here to here we're gonna come up. All right, so it's gonna be X to 5 equal the same story with 1, which we can get our X to be 5. And we got it, our AB is 5. Using the ratio property, the ratio definitions, subtraction law, and most important, the basic is foundation blocks is a perpendicular lines, because the angle doesn't change. Because of that, we can do all other stuff, all other lines as well. If we know the part of one lines, we can relate. If angles that didn't change, we can relate to the parts of the other lines. So which means if I want to do here let it be here y, and if I want to choose here, let it be any number until here, let it be any number until here, let it be let's choose another 4. Let's choose 12. If I want to choose 12, what's going to be if it's 12, for example? We can choose right now. We cannot choose this over this. It's not we're gonna choose to the whole until here. All right. Okay, what are we gonna do? 12 to 8. All right. Okay, 12 our case 12 to the whole part, the other whole part, which is 8. 12 over 8. Let me write down. Okay, BC. Okay, now B prime C prime over OB prime, which is 12 over 8. Now here we know already. Here we got 5 plus x, we got it as a 5, 10. So the other part, what's going to be? Which is equal to y over 10. And by the proportion rule, we can get y is equal 10 times 12 over 8. Which is here if we divide 4 divide 3 times 2 5 times 3 15. Okay, so y is 15. Here is a y is going to be 15. Okay, this we got it as 5, this is 15. So these cool properties relates to most of this. The most important fact here was one of the lines we're going to choose, and we need to divide it into small parts, and we need the measurement of those parts and how to find the other parts, which most important was the building blocks. Building blocks must be, all these building blocks must be perpendicular to each of to one another. It doesn't need to be under perpendicular angle. It can be any angle. All right. With this, it's very important. We can do similarity for the triangles. Similarity property for triangles. Similarity postulate for the triangles. For the triangles, what do we need for the similar? We said that all the angles must be the same. For triangles, we just need only two angles must be the same. The third angle we can figure out by subtracting 180 to the other two. So just need to be two angles. So imagine if we have one triangle, okay, like this. All right, triangle ABC, and some triangles somewhere here. Let me do like this. The important fact, okay, if this let it be some here B prime and here C prime, the point most important here, these two lines is parallel. If let's say if this triangle somewhere outside, let it be this, we need to make sure that the angles, two angles must be the same. The other angles automatically is going to be the same, then this will provide us its similarity. Okay, so if it's like this, perpendicular lines will provide us two angles are the same. These angles are the same as these angles, and I don't need the third angle. It's already related, which tells us this two triangle A B C is similar to triangle A B prime C prime. Similarity, and we have the special sign for similarity is this one. Okay, which means two triangles are similar with a similar, which means their sides are different, relates proportions somehow, but the angles are the same. Thank you very much.